Hi everyone. Maybe let's start with a show of hands. Who knows Replit, heard about Replit, or is even a Replit user? There you go, love it. Okay, that's the reason why we're in San Francisco. Everyone is in tech. So today I'm going to tell you what powers all our AI features at Replit. We're going to do a technical deep dive. I'm going to show you some of the latest features that we're building, and then I'm happy to take some questions. So first of all, for the few of you who didn't raise their hand, what is Replit? So Replit is a platform to build and collaborate on code in any language you can think of. We have more than 22 million users in our community right now. What we give them is basically a cloud computer where they can develop, run, and deploy applications. So we like to say that Replit is the best place to go from idea to software fast. And the company started in 2016. We have been growing quite a lot in the last couple of years. And today I will show you why AI is playing a key role in this growth. Our North Star is literally to speak software into existence. So this is a demo that we showed, I think just a few months ago. It went viral on Twitter. And what is going on in the background is a user is speaking to their phone, saying that they want to build a workout tracker. And we translate their speech into text. We feed that into our AI. We create a web application in the background. We deploy the application, and it's up there ready for them to work. Of course, this is working with a toy example today. You can imagine in the future, to be capable of building much more advanced applications with a more advanced version of our AI. This is our future. How are we going to make this happen step by step? And also, why are we excited to make this happen? It turns out that only a tiny fraction of the global population is responsible for our digital growth, which means we have roughly maybe 30 million developers today, and we are 8 billion people in the world. Roughly more than 5 million of them should have internet access. So why is there this wide gap between people capable of writing software versus people that are actually users? And I think most of the people in this room know the reason why. It's freaking hard to build software, okay? And we want to change the status quo. So how do we empower the next billion software developers? How do we make this happen? And we are the AI conference, so you could have expected that part of the answer, of course, has to do with AI. And our belief is that if you combine AI with software creation, you're going to empower the next billion software developers. If you've been attending the keynotes today, you've seen that, like every other medium, software is getting easier to make, especially Peter Norvig earlier today was talking about it. You can go from a mere idea to software in minutes, and it's becoming cheaper, basically, to make software. This will only make the demand go up, first of all, but also there will be a massive expansion to what it means to be a developer. It's not anymore those that do it professionally, but we expect this definition to expand across a much wider user base. So I like to bring up this example because at Replit we run monthly hackathons, and as you know, especially if you live in San Francisco or you hang out here, there are so many hackathon events happening pretty much every week. So what we do is we go and check people that are building with Replit, and we talk to some of them. It turns out that the vast majority of the people that are winning these hackathons happen to be using Replit. I bring up Priya's example because she has been a faithful attender of our events. And she recently won an hackathon in what was called a non-technical track. She has a PM background from Microsoft, but being a PM means that you can explain very well what are the requisites of your software, right? So PMs are exceptional at using large language models. And it turns out that with very little software background, Priya managed to win the hackathon and possibly build the best hack we have seen in a few hours. Priya's story is basically what we want to replicate at a large scale and make it to 1 billion people being capable to do what she was doing. How are we making this happen? So now we're going to get a bit into the weeds. I'm going to kick into a different gear, go a bit more technical, and tell you what it actually takes to empower our software developers with AI. First feature we're going to be talking about is code completion on Replit. We released this roughly a year ago. It has been evolving over time. If you have been using GitHub Copilot, you know exactly what I'm talking about. So it's a feature that gives you ghost text and tries to predict what you're going to be writing, maybe like a couple of lines of code, maybe a block of code, but the concept is the same. At Replit, we built it slightly different, and I'm going to get into the details of why we did it this way. But before I do that, let me bring up an interesting article that came out roughly a month ago. It's this GPU-rich versus GPU-poor analysis from, the article is from Semi-Analysis. The reason why I bring it up is I wanted to take an excerpt that I found amusing, in good and bad ways. So what it says is, there are a lot of people out there that don't have many GPUs, and they're actually wasting their time. I'm giving you a very succinct summary of what's on that paragraph. And the point is, from this analysis, the fact that only companies that have access to thousands of GPUs should be working on larger language models. Everyone else is wasting their time. So I hope by the end of this talk, I'm going to convince you that I disagree with this point of view, and I will try to tell you why this is the case. By the way, I'm very glad that people are working on mega models. I love GPT-4, I love Gemini, I love Claude. It's amazing, the capability of what they can do. I'm going to try to argue that you don't always need that kind of power to build a successful product. So it turns out that early, May this year, we released Replit Code V13B, which is a bespoke code completion large language model that is already in front of all of our users today. So we deployed it. It's available on Hugging Face, so we released it open source. Last but not least, we also released it with a commercially permissive license. So you can take the model, you can build products on top of that, just send me an email, say, Michele, this was cool, thanks for releasing the model, and we're going to be happy with that. Let me tell you how we built this model, and we made this happen literally in roughly a month of work with a last sprint for training, so it takes less time than you might imagine. By the time we released, it was the first Llama-style LLM for code. By Llama-style, I mean it was trained on almost 200 tokens per parameter. If you've been following a bit the history of large language models, you know that a couple of years ago, we were sort of under-training them. We were not feeding them with enough data. And then there's been this seminal paper from DeepMind called Chinchilla. They gave a rule of thumb where they said you should be training your model with roughly 20 tokens per parameter. And then the Llama family models came out from Meta, and we started to see yet another order of magnitude of more data per parameter. So the idea here is you spend more compute at training time, you make your model smaller, you make it more powerful, and you're going to be saving compute at inference time, because again, the model is smaller. So we trained this on a mixture with more than 525 billions of tokens of code. It supports 20 languages. It's specific on code completion, so it's not a generic model that can answer questions, but it does a pretty good job at completing your code. We built this on a data set released by a collaboration between Hugging Face and ServiceNow, if I recall correctly. It's called The Stack. It comes from a project called B-Code. If you are passionate about LLMs applied to software development in general, I recommend you to check the B-Code project. It's happening in the open source. They have an amazing Slack workspace. They have a lot of papers. So it's very interesting to follow what they're doing. And what they did is, in March 2023, they released Stack 1.2, which is a very large collection of GitHub repos. I think it's in the order of almost hundreds of millions. And out of this collection, we selected the top 20 languages that are the most representative for our user base. We applied then a lot of heuristics to keep only high-quality data. This theme is going to be recurring today during my talk. As you know, training LLMs on high-quality data is much more important at this point than training a larger LLM. Like, data quality is possibly the most important factor in getting a good large language model. So we put a lot of effort in cleaning up the data, and we did pretty much all of our work with open source tools. So another reason why I'm here today is for those of you that are not working in very large companies, that are kind of scared to approach the idea of training your own LLM. It turns out that things look much better than they did a year ago and even 6 months ago. So there is a lot available in the open source world that allows you to go from data processing all the way to doing inference of your model. I'm going to be having office hours later after my talk, so I'm more than happy, if you come and we want to have a chat and go in depth, I'm more than happy to tell you how we made this happen. Now, one key research insight that I think is also worth sharing is coming from this paper, Scaling Data-Constrained Language Models. It's a collaboration between Hugging Face, Harvard, and University of Turku. It has been coincidentally published a few weeks after we released our open source model, and I highly recommend this paper for one key result. Basically, what it says is the intuition is rather than having to collect a very large, high-quality data set, which is very hard to find / very expensive. As you know, large companies are collecting data by paying humans for creating annotations. You can actually repeat a data set for a few times without experiencing any decay in terms of performance. So the insight here is that if you have a high-quality data set and you repeat it 4 times in your training mixture, you're going to be getting pretty much the same results as having a larger data set of unique data. So we use this insight to work with the highest possible quality of data that we could get from the stack. We repeated it 3 to 4 times, and not only this allowed us to get a better model, but it also allowed us to release a model that has been trained exclusively on on code that has been released on permissive licenses, such as MIT, BSD, and Apache. And thanks to that, now we are able to release this model in a way that makes it commercially viable for you to use. Let's move now to model training. As I mentioned, it's a small model. It's not even 3 billion parameters. We train our own custom vocabulary. It's at 32K, so relatively small, very similar to what Llama and Llama 2 are doing. It's trained only on 256 A100 GPUs. So back to the GPU poor article that I was talking about before, the whole training process took 3 days on Mosaic ML. I can tell you can do the math. You can go and check how expensive is an A100 GPU for 1 hour on any cloud provider. You will find out that this is definitely not in the order of millions of dollars. Okay, so it's much cheaper than you might have expected. And we follow a recipe of LLM best practices. We're using flash attention, alibi embeddings, and so forth. So all these things put together gave us a model that is pretty powerful. Another pointer, again, to reinforce what I was saying before about open source, you don't have to be AI PhD to train your LLM today. Again, much different compared to how things were 1 year ago. There are very good open source solutions out there. We use Composer from Mosaic because there was the provider that also gave us access to the compute, and we have a partnership with them. There are also other projects out there. So if you want to get started on training your own LLM, you're not going to have to write the whole code base from scratch. There are solutions out there that basically bring you to 99% of what you need just by using open source software. Let's move to evaluation right now. I know that's always a hot topic when you talk about large language models. So the evaluation we run is something called, it's a benchmark called HumanEval. It has been released by OpenAI a couple of years ago in parallel with their paper called, their Codex paper, which was basically the initial AI engine that powered GitHub Copilot. And this benchmark looks the following way. It's a collection of natural language descriptions, and then you ask the model to generate Python code, self-contained Python code that you can execute. And the benchmark contains a bunch of tests or like assertions that basically check if the output of your code is correct or not. It's a very small benchmark compared to what you might have seen in the natural language space. It's solving 164 problems. That's as far as we are right now in the for benchmarking code solutions. I will dare to say we are lagging behind compared to natural language. I know, it is what it is. Everyone is working very hard right now. And rather than running this only on Python, there is also a newer version. There are a couple of solutions out there that allow you to run it across several languages, okay? So when you see score passed 1, say 22.5% on Python, it means that basically 1 time out of 4, the model generated first shot the right solution for that problem. If you think about it, for a model of this size, it's pretty exceptional that it can do so well just from an English description. It turns out that also when we released it, for this model size, we were extremely competitive, and you will see later on have a fine-tuned version of this model that gets very competitive also with much larger commercial models. But we're going to get there. So the other insight I wanted to give you is maybe helping you to read some of the benchmarks that you will find online. So the numbers I showed before are coming from the Multilingual Code Models Evaluation Project, still created by the Big Code folks. It's based on multi-PLE, which is basically as a multi-programming language evaluation, and it's an extension of the original OpenAI benchmarks I was telling you about. It's built over 18 programming languages. It turns out that we released our model before that benchmark suite became quite widespread, and the Replit model is trained only on 10 languages out of 18. So when you go and read the leaderboard, of course, we are not going to be scoring well on the 8 languages on which we haven't been training. And then we are quite below because of that reason. I bring this up because, unfortunately, we're still in a position, where if you want to build products with models, the best way for you to test them is to put them in production or put them in front of a few users, or even yourself. And if you're building your own startup, having what we call like a vibe check, like literally you using the product for a few days and figuring out if the model performs correctly or not, seems to be the best way today, to find out if an LLM is doing what you need or not. So it turns out that we have a lot of internal metrics after we deploy the model, and we got like 50% better compared to the previous solution that we were using. And to me, whenever you have a user base, and you know that deploying your large language model is not going to be disruptive, go ahead and make that happen. That's going to give you the most faithful signal if what you build is good or not. As promised, we also have a fine-tuned version, which we built in the following way. We took data from Replit. We have a lot of people writing code there. So we created another high-quality data set. This time is more than 100 billion tokens of code, which we repeat 3 times, as we did for the previous model. This is code authored by our users. It's mostly Python and JavaScript. Those are the 2 dominant languages on Replit. We apply exactly the same heuristics for filtering in terms of data quality, and we face a problem at this point. So for those of you who have been training LLMs, especially recently, you know that you have this issue where, say you have been playing with Llama. I know that there are a lot of people out there trying to do their own fine-tuned versions of Llama. What happens when you try to restart fine-tuning? It happens that your learning rate has dropped. There is always like some sort of decay that makes your learning rate smaller towards the end. If you go and try to restart it, you're going to have a warm-up phase, and then you're going to start to see basically loss spikes. This is pretty much well known in the community. What is the solution? There are some research pointers on how this could be solved. There is a very pragmatic hack that is coming also from the Scaling Vision Transformer paper. I will share these slides on Twitter so that you can go and find my links or ping me, and I'm going to be telling you some of the hacks that we made. It turns out that what worked for us is that tweet on the top left, which again was published months after we made our model open source. But I like to find out what experience people had recently to see if it maps with what we did a few months ago. What we did is we just kept training, and we experienced some loss spikes at the beginning of the fine-tuning, but then the model recovered, and then the loss kept decaying, and we got exactly what we wanted. So even here, my high-level takeaway is you will always find research papers that kind of pull the handbrake for you because they make you feel, oh, I'm going to be wasting GPUs, I'm going to be facing hard problems, the research community is still not there. There is always a mismatch between what researchers are trying to accomplish in terms of optimizing to the last flop, the training, versus what practitioners can do. So there are a lot of shortcuts and small, let's say, trade-offs that you can accept in order to make your life much easier and in order to obtain what you need. So here in this fine-tuning, go ahead, it's relatively feasible without understanding a lot of the research in depth. Now let's go back to the evaluation for the fine-tuned model. As you can see, there is a big gap between the base model and the fine-tuned one that we further train on Replit data. The reason why I'm showing you this table, the numbers in isolation, they don't really mean much, as always in a benchmark. What I like to show is, first of all, the gap. Like with some additional amount of high-quality data, you start to see like a big gap in terms of performance accomplished on the benchmark. So once again, I'm going to keep repeating this till the end of my talk, quality of the data is the most important thing when you're training your LLM. And the other point is some of these numbers, for those of you who have been dabbling with human eval, are pretty high. So 30% from a model that has been exclusively trained without any instruction fine-tuning is a very big number, especially for such a small model. It has been reproduced at this point, but again, when we released it, it was unheard of. Okay, training is fancy. It's a lot of fun. That's what makes the work in AI so intellectually stimulating. Training is nothing if you don't put your model in front of your customers, right? So we also focus on inference, which means we made the model small, and we made certain architectural choices in order to make sure that the model will be fast and cheap to serve. So we use a couple of projects from NVIDIA. One is Faster Transformer. The other one is the Triton Inference Server. As a heads up, Faster Transformer is on the way to being deprecated, or maybe it officially is. You should go and talk to Brian. And there is a new project called TensorRT LLM that is replacing it. But all of this to say, there are ways to take your model and optimize the inference performance by a order of magnitude easily. That's the reason why I also show, again, this leaderboard from the Hugging Face benchmark I was talking about before. When benchmarked with the standard Hugging Face inference code base, we are generating roughly 40 tokens per second. The solution that we run today in production is producing more than 200 tokens per second. It's exactly the same model, exactly the same GPU, we just get much higher throughput by means of optimization. So takeaway here is never despair if things are not as fast as you expected. There are always a lot of tricks out there you can apply to make your LLMs go much faster. The truth is, especially the last 6 months, what's happening in the open source community when it comes to inference is extremely exciting. I'm sure you have seen some viral tweets about people running models in local on their Apple Silicon, like M1 and M2s. Those models are freaking fast when they run on your laptop, so it makes you understand how exciting the future is going to be. Like, there is really a future where a lot of LLMs will run on the edge. Okay, last but not least, a lot of people ask me, why did you release this open source? Like, you're a company, you're a for-profit company, what is the point? First of all, Replit has been built on the shoulders of giants. Like, we wouldn't exist without all the amazing open source community that is out there. So we almost felt compelled to give back. Apart from that, it's pretty cool to release an open source model because people start to build amazing products and demos on top of that. So in the month after we released it, we got a couple of amazing forks of the model where people did instruction fine-tuning. They brought it all the way up to like 60+% on human eval, just from the same base model. There are also a couple of companies that are building their own, say, local version of Code Assistance, where the model is running on the Apple Silicon, as I was just mentioning. And I can't really keep track of everything that is going on, but that's another big incentive for you to think about making this happen in the open source. Okay, some links are here, a lot of acknowledgements. Again, reach out to me later. I'm happy to share the slides, and you can take a look at all the papers that I mentioned today. In the last few minutes I've left, let me show you also some of the other features that we have right now on the product. So we have a chat assistant as well that is deeply integrated in the IDE. And as you can see, what's happening here is we're not going to be writing a single line of code. We're asking our assistant to create a web application. You will see that there is that label on top that says using generate code. Based on what the user has asked, we classify that their intent is to generate code, and then we immediately drop the code into the IDE. The next request is change this app from Flask to Fast API. So we understand that you want to transform your code. We generate a diff for you. We ask you to review it, and then you accept it, and boom, and we throw it into your IDE. Now we're going to be wondering, okay, I have my application. How do I deploy it? And now our assistant understands that you're asking for our Replit documentation. We change the intent. We tell you that's the way in which you deploy apps on Replit, which, by the way, is one click. Run it, and you have your hello world. Oops, sorry, I don't have my laptop here, so I can't stop the video at the right time. But trust me, in this minute, we basically built a Fast API application from scratch, wrote 0 lines of code, click one button, and deployed online. So the pitch I was giving at the beginning of my talk, which is idea to software fast, you just saw this compacted in 1 minute of time. I didn't speed up the video, I promise. Now, if we bring this to one extreme, asymptotically, what we want to build at Replit is the concept of artificial developer intelligence. I made this pun on the REPL acronym. As you know, Replit, our company name, comes from the concept of REPL, so read, eval, print, and loop. We are rethinking this concept now with AI in the picture, and this new loop is going to be reflect, evaluate, percolate, and learn. It's much more advanced, but let me try to dig into detail and tell you what we mean by that. So first of all, after we understand what is the user intent, our ADI devises an execution plan, which means generates the code, figure out which code should be run, which tools should be invoked. Then we run it, And we run it either until completion. It means that we accomplished what we wanted, there is nothing else to do, or most likely in the first few iterations, our software will fail, as it usually does. Even if you are not an AI, but you're a human developer, most of your first iterations will fail. So what do? You go and check your stack traces, you go and check your errors, your console, and you try to figure out what is going on. Now, rather than offloading this task to a human, what we do is we percolate this feedback. We aggregate it, we find what are the key insights, and then we feed this back into our AI. And thanks to that, now we're going to be generating a new version of your software. We're going to be learning from the mistakes that we did before, and we're going to give you the next iteration. And this is a loop which hopefully we're going to close in a few iterations that in the end give you exactly what you're looking for. So this is my personal mission at the company. This is what I'm building with my team. For those who are looking for a job, if you're excited, come to talk to me. And last quick thing that I want to mention, then I think maybe I have a few minutes for questions, is this is a release that I think we did literally a couple of weeks ago. As my personal goal, I don't only want to make a very advanced developer AI within Replit, but I also want to make sure that generative AI is easy to use for everyone. For those who have been doing this for a while, you know that every time you want to use an endpoint, you need to understand their relative advanced API, you need to do key management, you need to be aware of billing. If you forget about it and your application goes viral, you end up giving $5,000 to OpenAI over a week. So there are all these different paper cuts when you build with Gen AI that we want to avoid for you. So we just released Replit Model Farm, which is basically the safest and fastest way for you to build applications with Gen AI. As usual, rather than me trying to pitch it, let me try to show a video. This time is only 15 seconds. You import our library, you copy-paste 3 lines of code, click play. This is the Replit experience. If you didn't even install the libraries, we automatically install them from you, and that's the output from the LLM. We're going to keep adding models to this. We're going to have image generation, code models, and we have a lot of cool ideas for the future. But that's where we're starting, and you know what's going to come next. Thanks, everyone. Happy to take questions.
Hi, great talk.
Thank you.
When you talk about taking a little bit of data and then retraining multiple times, there has to be a limit, right? I mean,
Yeah.
And I mean, how do we make sure that the model still generalizes? It's not just memorizing those. And what is that? How do you figure that stuff out?
Perfect. I didn't want to go into the details of that paper also because it's not my paper, and it's an amazing read. What they find is roughly at the model size that we trained on, you can repeat your data 5 times without any gap in terms of performance. The larger the model becomes, the less you can repeat without loss of generalization. They did quite an extensive amount of ablation studies. I honestly didn't have the GPU compute to make that happen myself. So we did a few ablation studies in-house, and it turns out that we had the right intuition. I do believe that you don't find a lot of results about that because, again, most of the research efforts today are on the very large models, and only now we're starting to focusing on the smaller ones. So I do expect that there will be follow-ups based on that result as well. But yeah, great question. Say 4 or 5 epochs, it's pretty safe at that model size. Thank you. That's one question there. Sorry for making you run around.
Yeah, thank you for the presentation. I have a question about incorporating libraries in the code generation, and also how do you keep up with when these libraries get updated and get a new version?
Great question. So in case you didn't hear is how are we going to support generating code based on libraries? How do we also support library updates? We're working on retrieval augmented generation for the code assistant. We have some demos already in place, and we're going to try to release it ASAP. And the idea there is we already have our own repository of libraries at Replit. As you can see, we install them automatically for you. So the vast majority of the top Python and JavaScript and Node libraries, they're basically available immediately. And we are building all the infrastructure to pinpoint what you're looking for and then bring it into the context of the LLM and then do the generation based on that. As always, we work at a much larger scale compared to a lot of ideas out there. So we have to do it right, and it's going to take us maybe another month or so, but you will get there by end of year. Thank you. I think I can take more questions because I'm out of time, but I'm happy to meet everyone at the office hours. Thanks.